Okay, solving systems of equations using elimination. In this case, we're talking systems of linear equations. Most books stick with that, although any sorts of functions would work for that, or even inequalities. Basically, a system is a pair or three or however many equations that all intersect at a given point, if you were to graph it, or for which you have a single solution that fits both or all of the equations, which sounds kind of complicated, but it's really not too bad. So there's a couple of ways you can end up seeing these, and you're going to have more or fewer steps to solve them depending on what you see. The first thing you're going to run into is this one. And you'll notice on this example that you've got a pair of 4x's. One's a positive 4 and one's a negative 4, but the numbers match. When you have the number in front of the x's or the y's match, you can solve the system relatively easily without a lot of steps involved. So, all I'm going to have to do is add or subtract to make these things go away. Since they have differing signs, if I were to add these, negative 4 plus 4 is 0x. So my x's cancel. Negative 2 plus 8, that would be a positive 6y. And negative 12 plus negative 24 is going to be negative 36. This now is an equation that I can solve. If you have more than one letter, you can't solve it. So elimination is a way to cancel out one of those two variables, one of those two letters, to find out what your answer is. So I would simply divide by 6 and divide by 6, and I would find out that y equals negative 6. All right, so that being done, get rid of that there. I'm not quite finished because I know what y equals, but to solve a system you also need to know what x equals. So you can take this thing that y equals and you can plug it into either of those equations up there. If you want to be sure that your answer is right, you will want to plug it into both of those equations because you should get the same answer either way. So if I take negative 4x minus 2 times, now y equals negative 6 because we found that out. That's going to equal negative 12. I can do that math. So this would actually be a plus 12. So I'm going to change that into a plus 12. And then I can do the math. So minus 12 to cancel it, minus 12. I'm going to get negative 4x equals negative 24. So x would have to equal negative 6 as well. So x equals negative 6. And if you want to write it down correctly, you would make it a coordinate point. You would say negative 6 comma negative 6 as a coordinate to write your final answer out, or simply x equals 6 and x equals negative 6, y equals negative 6. That should work. It depends on what your instructor is telling you is the right way to do it. So yeah, that's a lot of steps, but it gets worse. Lie to you. I'll never lie to you. The second way you could run into things is what you've got here. None of these numbers match. You've got an 8, you've got a negative 6, you've got a 14, you've got a 7, negative 7. You can't simply add or subtract to get rid of all these things. So we've got to change one. Now I do know that a 7 can be easily turned into a 14 by multiplying by 2. So I'm going to take that second equation and I'm going to multiply all the parts of that by 2. So the top equation isn't going to change. The bottom equation is now going to be negative 12x because negative 6 times 2 is negative 12. minus 14y for the same reason equals negative 20. Now I can add these up because I have a positive 14y and a negative 14y. So that's going to give me 8 plus negative 12 is negative 4x. My y's are going to cancel because 14 plus negative 14 is 0. And that's all going to equal 4 plus negative 20, which is negative 16. I solve my equation. Divided by 4, divided by negative 4, I should say negative. So x is going to equal negative 16 divided by negative 4 is a positive 4. Then, just like the last time, I'm going to take that and I'm going to plug it into either or of those first equations. So I'm going to take negative 6 times 4, and it's going in with the x this time because this time it worked out that we eliminated the y's and we're solving for x, minus 7y equals negative 10. So if I take negative 6 times 4, I can replace that with a negative 24. I'm going to add 24, and I'm going to add 24, and I'm going to find that y equals, I'm goofing that up. See, I'm not perfect either. Negative 7y equals 14, because that's what that works out to be. I'm going to divide by negative 7, divide by negative 7, and my y is going to equal negative 2. So there I have my coordinate pair for negative 2, or simply leave it in that format, and your life is good. Still a lot of steps, but it's manageable. The last method is the one that involves the most work, because this time I could easily turn a 7 into a 14 by multiplying. Okay, now this time, unfortunately, nothing here multiplies to make anything else. I can't turn a 3 into a 5, or a 5 into a 3, or a 4 or 9, or vice versa. There's nothing I can multiply any one of these by to keep it simple. So I've got to take the top part and the bottom part, and I've got to multiply them both by something to make my answers then have a number that they have in common. So the easiest thing is to take the coefficient from the second equation and put it up there, and the coefficient from the first equation and put it there, and do all my multiplying. And what that magically does is that gives me 15x plus 12y equals negative 90. Big number there, but don't be afraid of it. This is also going to be 15x, giving me my matching numbers. Minus 5 times 9 is 45y equals negative 18 times 5, which is 90. And now I can work this. So now this time notice that my x's are both positive 15, so rather than adding these two things, I'm going to subtract them. It works the same way. 15 minus 15 is 0x. My x's are gone. So 12 minus negative 45 is going to give me a positive 57y. And negative 90 minus 90 is going to be negative 180. Oh, wait a second, screwed up. So let's rewind. I like to leave my screw-ups in there because it's really easy to think that your math teachers are all perfect. So I like to leave those in here. I goofed up above because 5 times negative 18 would be negative 90. And if I take negative 90 minus negative 90, I'm going to get 0, which is a number that's going to work out for me. So y has to equal 0. That works. Negative 180 would have given me a super goofy answer, and I realized immediately I must have made a mistake, and I checked it. So once I know that y equals 0, again, I can plug it into either one of the previous equations. So I'm going to go 3 times x minus 9 times 0 equals negative 18. Anything times 0 is 0, so I'm going to just scrape out that middle part there. I don't have to deal with it anymore. And then last but not least, I would divide by 3, and I would find that x equals -6. So my final answer in coordinate form would be -6, comma, 0. Put that in parentheses, and life is good. So those are your 3 main issues you're going to have with solving systems with elimination. I did not add ones where the x's and the y's are shuffled around so they're not in order. These are all standard form. So if you have a problem like that and you don't know how to rearrange it, I will have a video somewhere on my feed eventually where I do the how to solve for a given form. Look for that or comment below with request, and I will immediately post that video. So have a lovely day.